Hello, welcome to another Year 10 Chemistry revision video. On this video today, we're going to be going through the 2018 double award paper that is higher tier. Question 1. Burning fossil fuels containing sulfur causes sulfur dioxide, SO2, to be released into the atmosphere. The table below shows the sulfur dioxide emissions in the UK between 1950 and 2010. First thing we've got to do is on the grid below is plot the sulfur dioxide emissions against the year and draw a suitable line. I'll let you check your points, but what you've got to be really careful with here is because we're going up in fives, every 2 squares is worth 1. So we're going 10, 11, 12, 13, 14, 15. So every little square is a 0.5. So check your points there now. Describe how the emissions changed between 1950 and 2010. Emissions increase until 1980, first mark, and then decrease. The UK government introduced a regulation to reduce sulfur dioxide emissions in the 1980s. From your graph, statewide it is difficult to decide exactly the year when the regulation came into force. Well, we've got 10 years between each reading, and emissions are very similar between 1980 and 1990. Sulfur dioxide can be converted to sulfur and water by reacting it with hydrogen sulfide. Complete and balance the symbol equation for this reaction. Well, we know we're going to form sulfur and water. Well, there's the sulfur and they form water, so I put H2O on the line. And then I've put 2, 3 and 2 to balance them. If you'd like to know more about that, please come and see one of the science teachers. Table 2. Show some physical properties of the group 6 elements. Describe the trend in the melting points of the group 6 elements. So I'm going to look in this column here. And the melting points go from minus 219 to 450. So down the group increases. Give the physical state of selenium at 400 degrees. So I'm going to look at selenium, which I've just put a little red star next to. Selenium's melting point is 221 and boiling point is 685. So 400 sits directly in the middle of those. So what that means is that selenium is melted, so it's turned into a liquid, but it is yet to boil. So we've got there, selenium is a liquid, and it is that 400 degrees is higher than its melting point, but lower than its boiling point. Explain why it is difficult to classify selenium as either a metal or a non-metal. Always, when we're not sure about this, is it has metal and non-metal properties. For example, it has a low melting point, but it is a semiconductor. Selenium dioxide reacts with sodium hydroxide to produce sodium selenite and water. Calculate the relative formula mass of sodium selenite, Na2's SeO3. So I'm using here the Mr. Timothy MR table. So you've got 2 times 23 gives me 46 for sodium. I've got 1 selenium and each one weighs 79. And I've got 3 oxygens, each one weighs 16. And that gives me 48. And when I add them together, we get 173. They then ask for the percentage by mass of selenium in sodium selenite. So selenium's total was 79. I then divide that by 173. I times by 100 and it gives me 45.7. Okay. The table below gives the compositions of 6 particles, A to F, which are either atoms or ions. Which particles are atoms? Well, what we've got to remember here, guys, is in an atom, protons and electrons are equal. Really important. So I can see that A has got 14 protons and 14 electrons, so that's one of them. D is 16 and 16, so that's another one. And E is 11 and 11. You don't have to worry with E that it hasn't got equal protons and neutrons. An atom is the same protons and electrons, and I've got my reason there. Which particles are positive ions? Well, we've got to remember that a positive ion has more protons than electrons. So for this one, we can see that B has 19 protons and 18 electrons. So it's B, and it's got 1 more proton, so it's a charge of +1. And F has got 12 protons and 10 electrons. So it's got 2 more protons, so it will be plus 2. Carbon has 2 isotopes, carbon-12 and carbon-14. Using these examples, explain what is meant by the term isotope. So the first thing I'm going to do is I'm going to remember my definition for isotope, and it's that isotopes are atoms that have the same number of protons but a different number of neutrons. So for example, C12 has got 6 protons and 6 neutrons, whereas C14 has 6 protons and 8 neutrons. I know that they have got 6 protons because if I were to look at the periodic table, my atomic number, my small number is 6, and I've worked out the number of neutrons by taking away those numbers. So I know 12 take away 6 is 6 neutrons there, and 14 take away 6 is 8 neutrons. The Earth is almost spherical. The diagram shows a section of the layered structure of the Earth. And I've got here the total thickness added up in standard form. The thickness of the crust at one location is 0.97% of the distance from the surface to the centre of the crust. So when they say the surface to the centre, it's all of those added up there. Use this information to calculate the thickness of the crust and give your answer in standard form. Well, the first thing I'm going to do is I'm going to add all those numbers together. 2.85 times 10 to the 6, plus 2.25 times 10 to the 6, plus 1.3 times 10 to the 6, and I get 6.4 times 10 to the 6. Please don't fall into the trap of adding up the times 10 to the 6s as well. Don't have to do that. I'm then going to find 0.97% of that. So I'm going to do 0.7 over what should be 100 times 6.4 times 10 to the 6. And that gives me 62,080. If I then go ahead and hit the Scooby-Doo button on my calculator, it then converts that to standard form for me, which is 6.21 times 10 to the minus times 10 to the 4. But if any of you were wondering, I can go put a dot there and I go times 10 to the 1, times 10 to the 2, times 10 to the 3, times 10 to the 4. Describe the theory of plate tectonics. So this question are asking us, what is Wegener's theory? So the first thing we need to remember, the Earth's crust is divided into tectonic plates. First mark. Second mark, these plates move very slowly. Third mark, the movement is due to convection currents in the mantle. Iceland lies on the mid-Atlantic ridge, which is formed at a constructive plate boundary. Explain the formation of the mid-Atlantic ridge. So really important here, they're asking us what happens at a constructive plate boundary, and that ridge is the new rock. So we've got to explain what happens at a constructive boundary and how does it lead to new rock. So I've used the names of the plates here, and it's a constructive boundary, so the North American and Eurasian plates move apart from each other. Magma rises through the gap and forms new rock as it cools. The rate of reaction between hydrochloric acid and calcium carbonate was studied. 2 experiments, A and B, were carried out. The same concentration of acid and the same mass of calcium carbonate were used, with the acid in excess each time. The volume of gas produced was measured for 60 seconds. The results of these experiments are shown in the graph. So let's just look at this for a second. We use the same concentration each time and the same mass of calcium carbonate. But I can see from the graph that curve A is steeper, which means it must be going faster than curve B, which I've done in blue. Using the particle theory, state and explain the 2 factors that may be responsible seen for the higher rate in experiment A. So there are 3 things in total we could look at, but there's 2 main ones here. The first one I'm going to talk about is temperature. And the second one is we're using calcium carbonate, which is a solid, which means the second one is I can turn my solids into a powder. So I'm talking about the surface area. So I'm going to talk about both of those now. First one, higher temperature, particles move faster, leading to more successful collisions and therefore a higher rate. And my second one was a larger surface area, more particles are able to be involved in collisions. I could have also spoken about here catalysts and said they've lowered the activation energy. State how the graphs show that the same mass of calcium carbonate was used in both experiments. Well, I want you to notice the exact same amount of gas was produced. So we must have had the same volume of reactant. So the same volume of gas is produced in both experiments. Explain the trends in the reactivity of the elements in group 1 and group 7 of the periodic table. So, 2 parts to this one. I got part 1, so I got 3 marks on group 1 and 3 marks on group 7, and I'm looking for the trend in reactivity. And I've got to explain it. So I'm going to be thinking about what is the trend and why is that trend the case. So group number 1, first mark. Reactivity increases down the group. Second mark, group 1 elements lose 1 electron in their outer shell when they react. Third mark, it becomes easier to lose an electron going down the group because the electron is further from the nucleus, meaning the attraction to the nucleus is weaker. I'm then going to go through the same process again for group 7. What is the trend and why is it that way? So group 7, the reactivity is the opposite this time. The reactivity decreases down group 7. The group 7 elements gain 1 electron when they react. It becomes more difficult to gain an electron as you go down the group because the attraction from the nucleus becomes weaker as the outer shell is further from the nucleus. A group of students were given 3 water samples. One was soft water, one was temporary hard water, and one was permanent hard water. To describe a method that students could use to find out which is which, give the expected results. You do not need to include the detail required to ensure a fair test. So first thing we're going to do, we're going to add 1 centimetre cubed of soap to 10 centimetres cubed of each sample and shake. We're then going to keep adding soap until a lather is formed and record that volume required. The sample that forms a lather with the least soap is soft. So that means I've got 2 hard ones left over. So I'm now going to boil the remaining ones and repeat. The sample that is then soft or requires a small volume of soap is temporarily hard because I've softened it with boiling. And the sample that still requires a large volume of soap is permanently hard. The samples from part 1 were labelled X, Y and Z and sent to have their iron content measured. The table shows the results. Now, first thing we've got to look at here is we're looking for what these ions mean. So, magnesium and calcium are actually in both permanent and temporary hard water. If a water sample contains hydrogen carbonate, it's temporary. And if it contains sulfate, it's permanent. Use this information to find out whether sample Z is soft water, temporary hard water, or permanent and give a reason for your choice. So first of all, we can see that solution Z has got a high amount of calcium and magnesium. So that tells me that it's hard. But then look, it's got a high amount of hydrogen carbonate, but it doesn't have very much sulfate. So Z is temporary hard water because the concentration of hydrogen carbonate is high, calcium is high, and magnesium is high. Sulfate is low, so it is not permanent. Permanent hard water can be softened by ion exchange. Explain how ion exchange works. First mark, hard water contains calcium and magnesium ions. Second mark, the exchange column swaps these with sodium. Explain why the resin in the ion exchange stops working after a continued use is because there's no sodium ions left. A litre bottle of mineral water contains 184 milligrams of dissolved calcium sulfate, CaSO4, really important there. Calculate the number of moles of calcium sulfate present. So the first thing I did here is I've drawn my moles equation. Remember, N is moles, M is mass, Mr is molecular mass. Give your answer to 3 significant figures. So what I want to do is they've told me that 1 milligram is 0.001 grams. Now what they've done there is they've divided by 1,000 to get back to that point. So rather than having 184 milligrams, I've converted that into 0.184 grams. I then, everybody, remember this, I've got some mass numbers and I've got a formula. So I'm now going to use the Mr. Timothy table to calculate the molecular mass. I've got 1 calcium that weighs 40, 1 sulfur that weighs 40, but I've got 4 oxygens, each one weighing 16, so I do 4 times 16 is 64. When I add the total up, I get 136. The moles, so I do mass over MR, I do 0.184, which is my mass, divided by my molecular mass, or MR, which is 136, and I get 0.00135. Now, I'll let you read that information in your own time. I'm going to go to the next page to show these answers to you. Put a tick in the box next to the statement which best describes why a single definition of heavy metal is not accepted. It's because metallurgists, physicists and chemists are concerned with different properties, so they can't all agree. Since the 1970s, the use of lead water pipes has been prohibited across Europe. Explain why this is the case. It's that water becomes contaminated with toxic lead that will build up in the body. Put a tick in the box in the 2 statements which describe the conclusions that can be drawn from figure 1. It's that lead contamination in roadside soil at all distances is much greater in towns than countryside, and that lead contamination in roadside soil decreases between 12 metres and 42 metres from the centre of the road. Then finally, in the mid-1970s, the use of lead in paint and the manufacture of cars that use leaded petrol was banned. Put a tick in the box next to the statement which best describes what happened after the ban. Is that it took 15 years for paint and petrol to become lead-free. Last question then, guys. First, ask you to do some balancing. 6, 2 and 6, come and see me and I can talk through that one with you. Now, we've got our next one, though, and I'm going to take a bit of time on this. So 11.36 grams of lead oxide contains 10.18 grams of lead. Calculate the empirical formula of this oxide. So first thing, I have to do the empirical formula table or grid where I have a column for each element. And at the top of each element goes the mass. Well, what I want you to see here is 11.36 grams of lead oxide. So the lead and the oxide together equals 11.36. The lead on its own equals 10.18. So the oxygen will be the leftover. So I work out the oxygen is 1.18 grams just by taking those away and working out this difference. So that's my first mark there. I then need to divide each mass by the mass number. So I get 10.18 divided by 207, which gives me 0.049. And I do 1.18 divided by 16 and I get 0.074. And I divide them by the smallest number. Now I've got a problem here. I got a whole number there, but this is a half and I can't round up. So what I'm going to do is I'm going to times both columns by 2 to turn them into both whole numbers. So the 1 becomes 2 and the 1.5 becomes 3. And what that tells me is my empirical formula is 2 leads and 3 oxygens. So my answer is Pb2O3. Well done, guys, on completing this past paper. What I'd like to do, if there's anything that you're stuck on, come and see me or one of the science teachers and we'll do our best to help you understand it. Good luck with the rest of your revision.